In synchronous motors, we are going to discussing about the rotating magnetic field theory. Now, the objectives are so here what is rotating magnetic field, how it's produced, and generation of three phase rotating magnetic flux and mathematical proof of so for production of so rotating magnetic field flux. So now generation of three phase rotating magnetic flux. So when three phase distributed winding displaced by 120 degrees, that means it is mechanical angle, 120 degrees is mechanical angle, is excited by three phase balanced supply. So it produces a resultant magnetic flux rotating in space as if actual magnetic poles were being rotated mechanically. So now here this is the sequence of generation of three phase rotating magnetic flux. Here they are showing in the directions and we are given are red, blue and yellow. So here this is the stator, and in the stator they are rotor in that slots in that you have so wounded the winding in the slots. So you see here, observe here S1, S1, S2 and S3. These are the R1, R phases, Y phases and B phases, and F1, F2 and F3. These are displaced by 120 degrees, three phases. So now this is displaced by the generation of three phase rotating magnetic flux. Here pi, the flux pi is, so pi r is in red color, pi y is in yellow color and pi b is in blue color. Here flux in y axis and it is time varying theta, it is a theta is in x axis. Here in x axis theta equal to 0 degrees, 60 degrees, 120 degrees, 180 degrees, 240 degrees, 300 degrees, 360 degrees. So here y axis is flux is varying with the time here. So the flux in R phase is started with the 0 degrees and then it is maximum, then goes to 0 and then goes to the negative and then goes to negative to 0, and this is the flux of R phase. And then next to the flux of Y phase is started at 120 degrees. 120 degrees. So now the similar way it goes on increasing positive and then goes to degrees of 0 and then it is goes to increase negative side and then it is goes to 0 downward. So now in the similar way B phase also So it is so displaced by the so minus it is displaced by the 240 degrees. Here 240 degrees. Here in general we are written the equation, the flux equation in different phases. For R phase the pi r is equal to pi maximum into sin theta. For Y phase pi is equal to pi maximum into sin theta minus 120. Now pi b is equal to pi maximum into sin theta minus 240. This is the generation of three phase rotating magnetic fluxes displaced by the, so each one is 128 120 degrees. So this is the rotating magnetic flux. Now the pi r is in reference, we are taking the pi r is in x axis, that is 0 degrees. And now next one is the y phase of flux is so displaced by the 120 degrees, and pi b is also displaced by the 120 degrees. This is the three phase vector diagram. So 120 degrees, 120 degrees, 120 degrees. This is the three phase diagram of the so generation of rotating magnetic flux. So now this vector diagram, the R phase and Y phase and B phase is displaced by the 120 degrees. So we are going for the some theoretical values. So when in the formula we are discussed previous slide. So when theta is equal to 0, so pi r is equal to 0. Substitute in previous equation, theta is equal to 0, pi r is equal to 0. That means the flux in R phase is 0 and in Y phase is so minus pi m, and that means here, so here pi y is equal to pi m sin theta minus 120. Substitute here theta is 0, will get the minus root 3 by 2 pi m. Here y phase of the flux is minus root 3 by 2 pi m, and B phase of flux is, so here we will get the root 3 by 2 pi m. So here when theta is equal to 0, the pi r is 0 and pi y is minus root 3 by 2 pi m, and pi b is, that is equal to root 3 by 2 pi m. So this is the, so here the flux when theta is equal to 0, here they given, they drawn here in the figures. Here observe this one. Next one is, therefore the resultant flux between these three phases, the resultant flux is, so pi r is equal to 2 into root 3 by 2 into pi m into cos 60 by 2. So that is equal to here 1.5 pi m. Whenever theta is equal to 0, the flux of the resultant three phase rotating magnetic field is pi r is equal to 1.5 pi m. So this is the resultant flux of the rotating magnetic field of three phase system. So now here this is the minus pi y and another one is pi b, and the, so these resultants, so see here, will gives the pi r, pi b and pi y, which resultant gives the pi r. So that is the vector diagram of rotating magnetic field flux. So now at theta is equal to 60 degrees, here pi r is root 3 by 2 pi m, pi y is, so pi y is minus root 3 by 2, pi b is 0, So here in pi r and pi y, these are two quite opposite. So here pi r is positive root 3 by 2 pi m and pi y is minus root 3 by 2 pi m. So the pi b is equal to 0, and here also the resultant flux of rotating magnetic field theory, pi r is equal to 1.5 pi m. So here also 1.5 pi m the resultant flux. See here the vector diagram is drawn here. The vector diagram pi r is here the resultant of pi y and pi r. Here the pi y and pi r is the resultant vector. So no. Here the see observe this one, the directions or they are giving the resultant vectors directions. So see observe this one. So pi r, pi y and pi b in for every 60 degrees they given. So observe this one. Observe this one. When here now here theta is equal to 120 degrees. What is the resultant magnetic flux, rotating magnetic? So when theta is equal to 120 degrees, pi r is equal to root 3 by 2 pi m and pi b is equal to minus root 3 by 2 pi m. So pi y is equal to 0. Here resultant flux is equal to 0. That is the resultant flux. Here pi y is equal to 0. Now go for resultant flux. How can calculate the resultant flux? Here in this case pi r is equal to 1.5 pi m. So whenever three phases theta is equal to 0 degrees, theta is equal to 60 degrees, theta is equal to 120 degrees. The resultant flux is, that means the rotating magnetic flux, resultant rotating magnetic flux pi r is 1.5 pi m. That is the 1.5 pi m. Here resultant is, what is the resultant? Pi r. How then we draw the vector diagram? Pi r is positive, pi b is negative. So pi y is 0. So what is the combination here? Pi r and pi b. Here pi r and pi b. So pi r and pi b. Here pi r and pi b. That means here minus pi b. So that, what is that? Minus root 3 by 2. This resultant which gives the, here see the vector diagram. This is the vector diagram. This is the vector diagram resultant. At theta is equal to 120 degrees. Now theta is equal to 180 degrees. Pi r is equal to 0 and pi b is equal to minus root 3 by 2 pi m. And here next one is pi y is equal to root 3 by 2 pi m. Root 3 by 2 pi m. So now pi r is equal to 1.5 pi m. Pi r is equal to 1.5 pi m. So now the resultant vector is in this way. So now this is the resultant vector current downward. It is the resultant vector downward. and theta is equal to 40 degrees. Pi r is equal to minus root 3 by 2 pi m. Pi y is equal to root 3 by 2 pi m. So pi r is equal to, not pi b is equal to 0. Resultant is pi r 1.5 pi m. This is the resultant. Minus pi r. Pi y minus pi r. Resultant, what is that? So which gives the pi r. That is 1.5 pi m. When theta is equal to 300, pi r is equal to 0, pi b is equal to root 3 by 2 pi m, and here resultant flux is 1.5 pi m. 1.5 pi m. So see here, observe this one. So observe this one. When theta is equal to 300 degrees, and theta is equal to 300 degrees, pi r is equal to minus root 3 by 2 pi m, pi y is equal to 0, pi b is equal to root 3 by 2 pi m. Now resultant flux pi r is equal to 1.5 pi m. So now this is the combination of minus pi r and plus pi b. Minus pi r and plus pi b. This is the resultant vector pi r. And theta is equal to 360 degrees. When theta is equal to 360 degrees, pi r is 0. Pi r is 0. What about the pi y? Pi y is minus root 3 by 2. What about pi b? That is plus root 3 by 2 pi m. The resultant is, see here, resultant flux is 1.5 pi m. Now the vector is minus pi m, is minus pi y is drawn in this direction, and the pi b is direction, and these two resultants will give the this pi b and minus pi y will give the pi r. This is the pi r value. These are the phasor diagrams. Different phasor diagrams for different of pi values, theta values. Hence we can conclude that the resultant flux is of constant value. The resultant flux is of constant value. So that means that is pi r. So that is pi r is equal to 3 by 2 pi m. That is equal to 1.5 pi m. 1.5 pi m. Here the resultant flux rotates around the stator at a synchronous speed gives by ns, that is 120 f by p, that is 120 f by p. Now figure 6a and 6b shows that graph of the rotating flux in a simple way. So now here see, observe this one. Two poles are only, here the poles are two poles. Very careful, observe this one. Here when north pole which attains the, so cross red here, the cross mark here, north pole is attend the cross mark here. Here the maximum of the value when the north is cross the dot value, it is negative maximum, it is negative maximum. So observe this one. Face A, face B, face A. As a clean, observe this one once again. The rotating magnetic field resultant is, the first one is downward and then it is moving right side, and then it is moving right side, and on it is in y axis. Now it is y2 between the y and x axis, and then it is moving right side, it is going, it is the direction of the rotating flux is, so clockwise direction. Here we are observing is the R by B phases, R phase, Y phase, B phase, by the phase difference is 120 degrees. As before, the positive direction of the flux phasor have been shown separately in figure 5. So here arrows on the flux's phasor are reversed when each phase is through 0 and become negative. Proof: for taking the direction of flux due to phase 1 as a reference direction, we have phi 1 is equal to pi m cos 0 plus j sin 0 sin omega t, and phi 2 is equal to pi m cos 240 plus j sin 240 sin omega t minus 120. And here pi 3 is the pi maximum, the cos 120 plus j sin 120, that is sin omega t minus 240. So here these are the pi 1 and pi 2 are here. The pi r expanding and adding the above equation, we get pi r is equal to 3 by 2 pi m cos omega t plus j sin omega t, that is nothing but 3 by 2 pi m cos 90 omega. So here pi m into 90 omega minus t. The resultant flux of constant magnitude and does not change with the time. Here they are telling the resultant flux is a constant flux. So that is the constant magnitude does not change with the time. Here the summary is So what is rotating magnetic field and how it's produced with three-phase supply, and mathematical proof for the production of rotating magnetic field. So this is the rotating magnetic field.